doing calculus are very, very complex. So let's say that you're dealing with like air resistance on a plane wing. The amount of air resistance that the plane wing has to deal with depends on the shape of the wing, the speed of the air, how many rivets are on the wing, whether the rivets are countersunk, the pitch, yaw, and roll of the wing, exactly what the wing's made out of, and a bunch of other things. So I just named off like 7 different variables. So that means that if you were to create an equation for that system, you wouldn't have it just as y equals some function of x. It would be y equals a function of x, y, z, gamma, omega, beta, and alpha. You'd have 7 different variables on the other side of that equation, rather than just having one variable. So wow, up until this point, you've been dealing with y equals and then having x on the other side, except for a brief stint in Algebra 2 and in trigonometry where you had x, y, and z. We're going to start dealing with systems that have y equals and then having 2 variables on the other side. Not just x, but another variable. That variable is going to be determined by what the equation is. So let's talk about what that would look like. So let's do a practical example first, and then we're going to start muddying up the waters. So let's say that you rent a car. So you rent a car for $40 a day and 15 cents per mile. So there's 2 variables there. How many days you're renting the car for and how many miles you drive it. Those 2 variables are what is dictating how much the car is going to cost when you return it. So that means the cost of the car is being dictated by how many days you have it out and also how many miles you drive it for. So it's not just like f of x, it's cost based on days and miles. So it's C of D and M. So instead of just doing like C of D or C of M, the cost is based on both. It's C of D comma M. Kind of, sort of. So in this case, C of DM would be equal to 40D, $40 times every day, plus 15 cents times every mile. Pretty simple so far, right? Okay. Let's muddy that up. So, no, I know, yeah, no. You just asked what you said. I'm throwing you softballs here to get you started. Let's go from a softball to a nerf ball to a... So let's say we have another function here. Let's say we have a function f of x, y, z, and w. Oh, because I don't know. You can do it. And it's equal to 35 x squared w minus 1 over z plus yz squared. And I want to evaluate this for f of 0, 1, 2, 3. So to do that, I would substitute 0 in wherever I see an x. To evaluate this, I put 0 in wherever I see an x, 1 wherever I see a y, 2 wherever I see a z, and 3 wherever I see a w. So this would be 35 times 0 squared times 3 minus 1 over 2 plus 1 times 2 squared. So that entire first term turns into, okay? So this is 0 minus 1/2. Oh no, yeah, no, we're just scratching the surface. Sorry? Yeah.
This is a curveball.
And so this is f of 0, 1, 2, 3 is equal to about tree 50. Well, no, equal to tree 50. I was just making a reference to a. No, I was making a pop culture reference. I thought I was funnier than I am. You're right. Put me in my place. No, Maria, put me in my place. You're right. I'm a 37-year-old man. I should not be making references.
You're dramatic.
No, you should make references.
You are ridiculous.
Okay. So, one more slow pitch, and then we're going to get into the hard stuff.
If that's a reference to anything, you can stop now.
Okay. So let's say we have a function here that is f of x comma y, and we're going to have the x's run along the top here, and I can. Yep. Yeah. The Loch Ness Monster. He wants tree 50. And then when they can't give him tree 50, he asks for 250, and they ask if there's a sale on Loch Ness Monster snacks. Okay. It's from When Chef Gets Married. It's from like season 3, from way back when I was in college. So I'm making a little table here. No, I heard it. Just because I don't like respond to anything doesn't mean I don't hear it. Oh, okay. Oh, it's just shush.
Like those charts that we have in the back of our book. I mean, our planner school.
Yep. It's not an actual multiplication chart though. I'm just making these numbers up. I'm totally just making these numbers up.
Okay.
These numbers are just coming out of nowhere. Okay. So if you have this chart, and I wanted you to find f of 0, 2, and you had the chart to read to find it. So 0, 2, 110. F of 3, 0 would be what? So 3, 0, 100. What about f of 3, 2? 475. Okay? That's the last slow pitch.
Let me think 3, 2, and 2, 3 are both 475.
Okay. I made these numbers up completely off the top of my head.
Is that 495?
Yeah. Okay. So that's the last slow pitch. Now we got 2 fast pitches to come.
Oh, no.
I know, I'm excited too.
Whoa, should have called it.
Watch it put that.
What is it?
Gosh, I solved it.
What?
Why is that?
No.
Y equals X. It's supposed to be a 3D graph. Coordinate system.
This is a 3-dimensional coordinate system.
What?
So this is not y equals x, this is a 3-dimensional coordinate system.
So it would be Y equals XD, right?
Okay. So, you have to imagine it as if, okay. So, the way that this works is The flat old XY coordinate plane that you're used to is this one here that's flat like this. The one that's coming up off of the paper is the z-axis. Okay? So the one that runs like this, let me show you. Okay, so the other way that you can think of it too is using your fingers. So coming up is the z-axis, x-axis, y-axis.
Oh. Okay, I thought you were like actually coming off of the paper. I'm like, no, mine's all flat. Can we
So-
plant them? So,
Okay, let me mark them here for you, all right?
yeah, that's a good idea.
So this is z. Let me zoom out a bit here. This is x, and this is y. They are at a 90-degree angle. You're looking at it as if you're looking at it from up above. You have to think of this as a two-dimensional representation of something that's three-dimensional. You're looking, like, the camera is here, looking down at it. This is really, imagine that this is z coming up off of the paper.
Okay.
We're trying to represent,
Doesn't make sense, but okay.
we're trying to represent something that's three-dimensional on a piece of paper.
Oh, I see. If you hold your paper up and look at it, you're
Right.
always like this. Okay, there.
So like here, if you're looking at it here,
Okay,
going
if
up.
you look right in front of it, imagine y is like a table, and then z is something sticking off of the table going upward, right?
Yeah,
And then x would just be going in the other direction.
Yes.
On that same table.
exactly.
Okay.
So like the x and y axis are a flat surface, like a table, like Maria said.
Oh,
They're a flat surface, and then z is like a line coming straight up out of that flat surface.
can I draw it?
Sure, go for it.
Okay. Oh, I totally- okay.
No, any more extra people trying to explain it is always a good thing.
And then this would be your z. Yeah. I'm looking at it like this. Oh, boy.
Okay, so
It doesn't flat off.
So the xy axis that she drew is like the table, like the flat surface, the plane, the xy axis you're used to. We took it, we dropped it down on its like,
Okay, yeah,
just
so
on its
if you
face.
look here, I'm like, but that would be like, cause like that's like flat like on this.
Yeah.
You got your
When I
X
hold
on
up my
the table.
paper, it would be nothing like that.
And then the z axis is coming up out of it.
What just bothers me is it's like X and Y don't, you know what I mean?
Mhm.
When I visually look at it. It's
Okay.
like, that's what, like,
From,
that's
if you were
what-
looking down on Z, they would be at 90 degrees, right?
Mm-hmm.
Okay.
Yeah. They're not at 90 degrees on the paper now because we're looking at it from an angle down. We're looking down at it from like a 45-degree angle because we have to be
If they
able.
were at 90 degrees drawn right now, the x-axis would be right below the Z.
The z and the axes would be lined up together. In order for them to look different, you have to look like those two aren't at a 90-degree angle with each other.
But that's even like closer to.
Imagine it like you're looking at a corner of a room. Like, let me turn the light on.
Like if you thought about like a building with like a sign on the side of it, and you look at it from the side, the sign's not going to be completely straight with where you're standing.
Like if you look at the corner of a room, the corner of any room, you've got, like it doesn't necessarily look like those
So how do
two.
we graph something on here?
That's what I'm getting to. That's the first hardball, is graphing something in an XYZ coordinate plane. The second hardball is finding the distance between 2 points in an XYZ coordinate plane. Okay? So,
It's no longer the value of zero.
it still is,
But
it super still is. We'll get to it. Alright, turn this back off to show you how to graph stuff on here. So, we're going to deal with XYZ coordinate points. So, I want to try and graph let's do 2, 4, 6.
So which order do these fall in?
Alphabetically.
X, Y, Z?
Alphabetically. So I'm going to graph 2 on the x-axis, 4 on the y-axis, 6 on the z-axis. So to do that, I'm going to kind of trace my path as I go. So I'm going to go 2 on the x-axis here. I'm going to go 4 on the y-axis here. So 2, 4, and then I'm going to go up to 6. So hold on, let me grab a ruler here so you guys can see what I'm doing. There we go. And if you want to, my rulers are in the drawer over there, marked rulers, so that you guys can do what I'm doing too. Because you end up kind of making a rectangular prism in order to find the point. So you're not just drawing a single point, you're drawing a rectangular prism. So I'm drawing a line that's parallel to 2 on the x-axis.
Parallel to you.
Well, like I'm drawing 2 out. Or not parallel to 2, that goes through 2 and is parallel to the y-axis is what I meant to say, sorry. I misspoke. I'm going to draw something that goes through 4 and is parallel to the x-axis now. Now I'm going to draw something that goes through 6 on Z and is parallel to the y-axis. Now if I connect this point down here, where X and Y met, to that line I drew, and have that line that, like, if I
What did you do?
Okay, let me walk you through it. Okay, this line goes through 2 on the x-axis and is parallel to the y-axis. This line goes through 4 on the y-axis and is parallel to the x-axis. This line goes through 6 on the z-axis and is parallel to the y-axis. Now I have this point where these 2 lines met.
Just draw up.
I drew straight up to the other one, and that point where I intersected, that's 2 out, 4 over, 6 up.
Okay, I have a question.
Yes.
So before you started explaining all this, I thought I could just like jump right in. And when I did, I found the same exact point. Right? So, is the drawing necessary though? Like drawing out the,
No,
okay.
I think it helps. If it's not helpful and you think you can find it in a different way, that's fine.
Okay.
This is just how I kind of do it. And it's how the book suggests it's doing, but
Is there a way to use math to figure it out?
this is the way to use math to figure it out.
Well, I feel like there's a lot of error drawing parallel lines with these, with just a ruler and stuff. Because, like, your lines aren't completely parallel.
No, they're not. But like I could make them completely parallel by like actually lining it up. I didn't do a great job.
No, but like there has to be some error involved when you do it.
Yeah, there is.
We're not computers.
Are you okay? I feel like I'm not answering your question very well.
Well, you admitted that there could be error, but
Yeah.
so I didn't know how you used to find the exact answer.
Use a computer. Okay.
Your answer then?
Yeah, just the point. If I ask you to draw the points, it would just be the point. Now, on your assignment, I think I only have you do that like once or twice. Let me look at your assignment here real quick. No, you just have to, well, I have you do it a bunch on your assignment, but we'll get to that. Now, for the calculating the distance between three-dimensional points here, which is why I had you do the distance formula for your warm-up, to try to remind you guys about that good old distance formula. So, we will look at find the distance between.
Would you just add Z1 and Z2?
Yep. So find the distance between, and then the 2 points we're going to look at finding the distance between. And this, I'm just going to take this directly from your assignment I'm going to give you guys. Let's do 6, 2, 1, and 3, 2, 1. Oh, that one's cheap. No, that one's going to be too easy.
Are they gonna be green?
Right, that one's going to be too easy. So let's not do that one because that one's too easy. Let's do a harder one for your assignment. Sorry.
But that one's still gonna be on our assignment.
Yeah, that's on your assignment.
So that'll definitely probably take
Yeah, so let's
Okay,
do
6 minus 3.
let's do -1, 5, 0.
When you label something on, like, would it be units cubed or units squared?
It's still a linear distance, so it's going to be units squared. So -150 and 132. So we're looking for the distance between these two. All right, so we need to find the so the distance for something that's in 3 dimensions is x2 minus x1 quantity squared plus y2 minus y1 quantity squared plus z2 minus z1 quantity squared, and then it's the square root of all of that. So 1 minus -1 is 2 squared. 3 minus 5 is -2 squared. And 2 minus 0 is 2 squared. Yeah, I'm trying to get it. Hold on. I'm trying to get it so it's not going to like immediately fall over. Okay. So this is going to be 4, 4, and 4. So this is going to be the square root of 12.
I got 2 radical 3.
You are right. Square root of 12 is 2 radical 3. All hail magic calculator. Bless you.
Thank you.
That's it.
Is it just 2 radical 3 units?
So yeah, just units, because it's a linear distance. Okay. So
Linear doesn't convert, like, if you calculate it doesn't reduce the radical.
you have to reduce it by hand like an adult.
I'm an adult.
If it's
Okay.
if
Magic.
It's an even number, try dividing it by 4 first.
Right.
Yeah.
Right.
I know how to reduce them.
Your algebra 1 teacher taught you how to reduce radicals.
Well, I mean, it's Brody and Kim
So,
probably
well, I
used
mean-
their calculators to figure that
No, my
out.
calculator didn't. Oh, yeah, I guess my calculator.
Your pre-calculus teacher taught you how to do it too.
Nope.
I didn't,
Yeah, he did.
I didn't have.
I've had long conversations with him. He taught you how to do it.